Hello, ladies and gentlemen. We're going to talk a little bit about slope-intercept form of a line here. I'm going to try and show you all the different ways you might be asked to write the equation of a line in slope-intercept form. The first thing we're going to do is just going to start off with some basic vocabulary here. It says a linear equation of the form y equals mx plus b is written in slope-intercept form. Now, mathematicians are not particularly fancy when they name things. We call this slope-intercept form because m is the slope and b is the y-intercept. So it's called slope-intercept form because it tells you two things, a slope and an intercept, specifically the y-intercept. So when we're trying to graph an equation in slope-intercept form, the first thing you want to do is make sure you isolate y, and then we'll start at the y-intercept and we'll count the slope. So let's go ahead and do a couple of these. First thing, it says y equals, so I know I'm in slope-intercept form. Then I can look and say, well, it's mx plus b. So in this equation, the m is -2 and the b is 6. Now I always write my y-intercept as an ordered pair, so I'm going to put 0, 6 because that is a point. So when I graph this, I'm going to start at 0, 6, that's the y-intercept, and I'm going to count the slope. Now if the slope is -2, just remember that's -2 over 1 if you are trying to think about it in terms of rise over run. So we're going to go down 2 and we're going to always run to the right. So down 2, 1 right, down 2, 1 right. And I'm going to do this a bunch of times, and I would encourage you to do it as many times as you can in this piece of paper. Now, the same thing as going down to right 1 is going up to left 1, up to left 1. So we can create all these different points on this line. Then we're going to use a straight edge. I got my computer to help. And there's our line. So you start at the y-intercept, and then you count your slope. This one is not set up as slope-intercept form. It's not y equals. So we need to get y by itself. That means we need to subtract 2 on both sides. And now I have 1/3 x minus 2. So the slope is right here, 1/3. And the y-intercept is -2. So I'm going to write that as 0, -2. Again, that's an ordered pair. I think it's important you know what you're looking at. If you just put -2, sometimes people are like, what is -2? It's a point right here, 0, -2. The slope is 1/3, so I'm going to go up 1 over 3, up 1 over 3, up 1 over 3. And I'm also going to go down 1, left 3, down 1, left 3. 1, 2, 3. It's hard to kind of do. Well, 1, 2, 3. There you go. Then I'm going to use a straight edge again and connect the dots. So those are graphing lines in slope-intercept form. You have to make sure it's in slope-intercept form, identify the slope, identify the y-intercept, start at the y-intercept, count your slope. What if you're given a table? So if you think of slope as change in y over change in x, that's rise over run. The change in y, we're going to look and we're going to see how is y changing from -13 to -18, from -18 to -23. We are subtracting 5. So the change in y is -5. The change in x from -8 to -4, from -4 to 0, from 0 to 4, we are adding 4. Plus 4, plus 4, plus 4. So the slope is the change in y, -5, over the change in x, +4. So then the slope would be -5/4. Now, if we're going to write the equation in slope-intercept form, which is y equals mx plus b, we know m, but we don't know b necessarily. So what I'm going to do is, in this equation, I'm going to see if I know the ordered pair for the y-intercept. The y-intercept is when x is 0, that's right there. So in this equation, since I am given the y-intercept, I can say b is -23, or 0, -23 is the ordered pair. So now when I want to write the equation, I can say y equals m, the slope, -5/4 x minus 23. The y-intercept is always where x is 0. So if I can find that point, I can just go ahead and write the equation. You're not always given that point, so let's do one where you're not given that point. We're going to find the change in y over the change in x. So from 12 to 24, we're adding 12. From 24 to 60, oh my gosh, we're adding 36. Okay, interesting. From 60 to 84, we're adding 24. So these aren't all the same. That kind of makes me nervous, but we'll look at the y's and decide if we need to worry. -50 to -47, I added 3. -47 to -38, I added 9. And -38 to -32, I added 6. So is this the same? 12 over 3, does that equal 36 over 9? Does that equal 24 over 6? So changing y over changing x. These are actually all the same. They're all 4. The slope is 4. So they didn't count by the same interval over and over again, but since they corrected it in the y's and the x's, it ends up being the same slope. The slope is 4. But I'm not given the y-intercept in this equation, so one strategy you can use is you can write an equation. We can say the slope is 4, but we don't know b, so y equals 4x plus b. We're going to pick any of these points. It doesn't matter which one you pick. I'll just pick the first one. And I'm going to write an equation. So y, I'm going to use this xy pair. X is negative 50, so 4 times negative 50 plus b equals, the y is 12. So 12 equals negative 200 plus b, and if I add 200 to both sides, I get 212 equals b. So the y-intercept in this equation is 212, so y equals 4x plus 212. Now, that's kind of a crazy y-intercept, so what I'm going to do is I'm going to pick a different order pair and just see if it works. If I plug in negative 38, I should get 60. So what I'm going to do is use my calculator here. Hang on, calculator. Right here. And I'm going to do 4 times negative 38 plus 212. So I'm testing my equation. If I plug in my x value, I should get my y value. I should get 60, and I do. So I know I did it right. I would encourage you to always try a different point after you've written the equation just to make sure that you found the correct y-intercept. That's if you're given a table. What if you're just given two ordered pairs? Well, another way we talk about slope is using the equation y2 minus y1 over x2 minus x1. So it helps to label these points x1, y1, x2, y2. And you can see my other notes on slope-intercept form here to help more examples. Negative 3 minus 17, y2 minus y1 over x2 minus x1, 12 minus negative 18 is negative 20 over. When you subtract a negative, that's the same as adding. So this is negative 20 over 30, which will reduce to negative 2/3. So a little bit more work to get the slope, but that's okay. We've got it now. We need to do the same thing we did before, where we wrote y equals mx plus b. So what I'm going to do is I'm going to write an equation. I'm going to say y equals negative 2/3 x plus b, and I'm going to plug in an ordered pair. So I'll pick this guy right here. 17 equals negative 2/3 x plus b, and I'm going to go ahead and solve for b. I didn't plug in my x value. I'm sorry. X is negative 18 plus b. So now, if I do negative 2/3 of negative 18, which I can do very quickly, I'll use my calculator to make sure, it should be 12. 12. So 17 equals 12 plus b, and if you subtract 12 on both sides, you get b equals 5. So my equation is y equals negative 2/3 x plus 5. Okay, got one more. To find the slope and y-intercept for this last one, we need to isolate y. So to isolate y, what I'm going to do is first subtract 8x on both sides. Negative 7y equals negative 8x minus 84. And then the last thing is we're going to divide by negative 7, but we have to divide everything by negative 7. So that's y equals, that's just 8 over 7. And I don't think that 84, 7 goes in 84, but let's just make sure. Oh, yeah, it does 12 times. So plus 12. A negative divided by negative is positive. So 8/7 x plus 12. So that's pretty much everything you could be asked to do with slope-intercept form. So good luck.